an equation like this moving forward? Huh?
I don't.
Okay, then why aren't you asking questions? What question do you have to get started?
How would you start this off?
Well, what are we solving for?
A.
This thing right here?
Mm-hmm.
Okay, what's happening to A right now?
Then multiply by 8.
Okay, then
Add B,
adding B, then,
divide by C,
then,
subtract by D,
then
equals E.
equals E. Looking at the left-hand side, the only thing the things that are happening to A, what was the last thing that you said that's being done to A?
Subtract by D.
Subtraction by D?
So
Add
add
Oh. So the inverse of subtraction is
addition.
addition.
I remember.
Yeah, what's negative D plus D?
0.
0. Notice the language right here is the inverse of subtraction to create a 0, and we had to do the addition property of equality. We had to make sure it stayed equivalent, right? This equation and this equation in purple, they look different. But because I used a property of equality, they are effectively the same. Now I'm not going to go through every step, because we should have attempted this with homework, and also because you can actually do this on on Symbolab, and it can tell you the answer. You just have to think through why. So now, what would be the last thing being applied to A?
Division.
Division by
C.
C. So Destiny, what's going to undo division? Destiny.
Oh.
Notice right here, we said the inverse of subtraction was addition. Multiplication, right? What would I multiply by here? C. That's all you have to think through. Now, you do need to remember that I need to multiply the entire left-hand side and the entire right-hand side by C, so I put parentheses right here. But notice, what is C divided by C?
C.
Nope.
0.
Nope. What's 5 divided by 5?
1.
What's negative 17 divided by negative 17?
1.
What's x divided by x?
1.
So what is c divided by c?
1.
I don't want it to be a 0, because what would 0 times anything be?
0.
So I don't want a 0 there, I want a 1, because what's 1 times anything? Just that anything, the same thing, right? ax plus b is equal to e plus d times c.
And then subtract.
Yeah, notice we're trying to solve for a, the last thing being done now is adding b. So I subtracted by b. Now the only thing being done to a is multiplication by x, so I divided by x.
I remember.
I want to point this out though, we would be able to do this much quicker if you had just attempted the homework. If you had put the genuine effort in to try it. We just don't.
I thought we were doing the same thing as the other homework, just makeup.
I very clearly showed at the end of class what the homework was. I need y'all to pay attention. I know that y'all are taking a test and getting things wrapped up for that, but that's what was happening. Okay? I'll make sure I get all of this week's slides and videos up online tonight so that if you need to look at this some more, it'll be on Schoology. You just have to pay attention to what unit we're on. We're finishing quadratic functions. Here is the review homework from last night, from May the 6th, right? Yep. What questions do you have about solving the inequality, about the set notation, the interval notation, or the graph? Now, we'll point this out. You had to justify for the last one because I asked you to explain each step. Have I justified anything here?
No.
No. Do you think I'm going to expect you to do that for the homework? That's a hard yes. Is there ever a time I don't expect you to justify? Nope. Unless I specifically say don't justify, I expect you to justify. That's why I keep your homework questions to 3-4 questions in total, because I do want you to justify, I want you to think about this stuff. Again, I didn't show many steps here, just showed the results of using the inverses.
With the interval notation,
Mm-hmm.
so don't the bracket mean it would be equal to, right?
Mm-hmm.
So, but on the number line,
Mm-hmm.
point is open.
Mm-hmm. Why is that a point open on the number line? How do you know it can't be equal to?
It has the thing,
Remember, it's based on this.
yeah.
Oh yeah, it don't say it would be less than or equal to or greater than.
Yeah, it doesn't say greater than or equal to, it just says greater than. Remember, we call that a strict inequality. It has to be above that number, right? Notice, if you check the number 3, is 3 greater than 3? No. So 3 is not a, starts with an S,
Solution.
solution. 3 is not a solution. That's why it cannot be included. That's why it is an open point and not a closed point. It is not a solution. Any questions about how I solved it, how I wrote the set notation, how I wrote the interval notation? Yes, CJ.
Like, how do you solve inequalities like this?
What's throwing you off? Well, let me ask you this question. What did we do with the equation on the last one? We found the last operation being applied, right? And then we undid it. Okay? There's 2 actual ways to solve this inequality, but notice, what's the first thing happening to x?
Multiplication.
You sure about
I
that?
mean, minus 5.
I was saying, because I see parentheses. That means I have to subtract by 5 first, right? After we subtract by 5, then what are we doing?
Multiply.
Multiplying by. So what do I need to do to undo multiplication by -2? Divide by -2. It's exactly the same thing as before, right? -2 divided by -2,
Yeah.
not
I mean
0.
1.
1. That's how I got x minus 5.
So, alright. Yeah.
And then 4 divided by -2 is -2. But RJ, there's something a little weird up here. I want to see if you can explain it. Why did this less than symbol become a greater than symbol?
By negative.
We divided by a negative. We got to keep that in mind. That's the only thing that's different about inequalities, CJ. If you divide by a negative or you multiply by a negative, it's going to reverse the direction of that inequality. But you're still just applying inverses. You're still just using the properties of inequality. Okay? Now, that's the way I solved it. That's not how most students would solve it or did solve it when they tried it. Any guesses of what most students did when they had -2 times x minus 5?
Distribute.
Most students distributed. Should it make a difference?
No.
So let's find out.
No, because then you'll still use the same steps eventually.
Well, what am I going to do now?
Subtract 10.
Subtract 10. 10 minus 10?
0.
Do I need to reverse this inequality now?
No.
Why not?
You got to divide.
Subtract, not divide.
I'm subtracting, I'm not multiplying or dividing, okay, so still good. Now what would I do?
Divide.
By?
I mean, -2.
Okay. -2 divided by -2?
1.
1, right? 1, because 1 times x is
X.
x. I divided by a negative, so
Greater than.
greater than? Same answer? Yeah. Okay. It doesn't matter which way you solved it. I did the, operations, the last operation being done, man, that made me jump. I wonder if I can watch it in the video later. I'll check.
I thought you were a MacBook.
I know, I did too. I was like, oh no! So there's that. Alright. Ready to move forward? No more questions about interval notation or set notation or the graph. RJ, are you doing math or are you typing on that laptop? Huh? Okay. Really quickly, I want to point this out. How many solutions are there to this inequality?
Infinity.
How do you know?
Because the arrow keeps on going.
The arrow keeps on going. There's a comma here in between the 3 and the infinity, meaning it's what numbers between 3 and infinity? Every number, right? That comma means literally every possible number in between 3 and infinity. Notice, because it's shaded, is 5 a solution?
Yes.
Yeah? What about 6.1? What about 7.1? What about 2.9?
No.
Right? Remember that shaded region is indicating every point that will make the inequality true. We good? Alright. So hopefully we can do that for the homework tonight. Today's agenda, we're going to be exploring the features of parabolas. you should already be logged into your computer. Is it not working? Not working? Okay, hold on. You should already have a sheet in front of you, so just look at this for a second, RJ. Where are we going to go once we log into our computers? Desmos, right? So go ahead and log into Desmos. Did you try this one yet, RJ? No? Okay. Yeah, sorry, I put that over. So go ahead and log into Desmos. Go ahead and put in the code and join the activity. Hey, are y'all logged into Desmos already? Got the activity code in? Okay. Yeah, this one should work. Let's find out. Hold up.
Do you still have the dark mode on? No, it's actually.
Oh. Alright. Raise your hand quickly if you are in Desmos. Alright. Got 1, 2.
You said if we in Desmos?
Yep, if you're already logged in Desmos, you got the activity pulled up. Okay? Keep your hand raised. Okay? Emmy's still getting there. CJ, Dwan, you're in. Okay, is that one working, RJ? You're good. Put your hands down. You good? Alright. While RJ's still figuring that out, let's look at the agenda for today and look at the objectives, and hopefully RJ will be caught up and ready to go with us at that point. So, really quickly, what was last unit all about?
Linear and exponential function.
Last unit was about linear and exponential functions?
Last year?
Last unit,
Oh.
the thing we just took a test on,
Oh, quadratic.
quadratic functions, okay? Specifically, what about quadratic functions?
Parabolas.
Uh,
Change.
the rate of change, where do we see the rates of change?
Linear.
No, where did we see the rate of change?
Oh.
In a table,
Representation.
where do we see parabolas?
On the graph.
On the graph. What else do we look at?
Algebraic expression.
Algebraic expressions, right? The recursive equations, the explicit equations, all those different things. So we looked at what was the nature of a quadratic function. This unit, we're focusing on the different quadratic equations. Okay?
Cool.
And so what we're going to do is try to connect the quadratic equation to what we see in a graph to start. Okay? So we're going to focus on the different quadratic equations. And so that's why it says exploring features of parabolas, connecting the equation to the graph of the parabola. So objectives, right? We're going to look for and make use of structure. We're going to determine how values in the vertex form of a quadratic equation affect the parabola. Okay, have any of you ever heard of the vertex form of a quadratic equation before? No? When we talk about
You said
the...
something about it yesterday.
Well, we've talked about vertex before for sure, two or 3 days ago. But when we talk about the point slope form of a line, what 2 things should you be thinking about? Point and a slope, right? So if we're looking at the vertex form of a parabola, what do you think we should be focusing on?
Quadratic.
The vertex.
Thank you!
Oh.
Point slope tells us to look at point and slope. Vertex form would be looking at the vertex. Okay? We're going to then also look at the values in the standard form of a quadratic equation to see how they affect the parabola. It's in some ways similar to what we would say from standard form of a line. It's a little different because the standard form of a line was what? Come on, standard form of a line. Somebody. Even if we have to read it off the wall, we should already know this.
And then slope intercept.
AX plus BY equals C.
The standard form, remember, was AX plus standard form, AX plus BY equals C. We'll look at the standard form of a parabola or of a quadratic function, and it's y equals AX squared plus BX plus C. Notice that A, B, and C are still showing up. We'll look at that. And then determining the values in the factored form of a quadratic equation and how they affect the parabola. If we're looking at something factored, what's happening to the factors?
Changing, moving.
Give me two factors of the number 6.
3 and 2.
What are you doing with that 3 and 2?
Multiplying.
So what do we do with factors? We
Multiply.
multiply. What would we be multiplying when it comes to a quadratic function?
Linear.
Linear expressions,
Yeah.
right? So we're going to look at things like this to understand how those linear expressions affect the quadratic function, right? So notice these names are not made up, they're not random, they're telling us important information. That's why I bring this up and focus on that as we work through this activity. So, we should all see a screen that looks like this, right? Adjust the value of A and observe what happens to the graph. We all see that right now?
Mm-hmm.
Okay, two things before we get started on this. What form of a quadratic function or quadratic equation do we currently have?
The graph.
What form of a quadratic equation do we currently have?
Somebody recursive explicit?
It's recursive.
Not there.
Do we have f of n and f of n minus 1?
No.
No? Has anyone looked at the sheet of paper that we're supposed to be taking notes on today? Or maybe at the slide?
It's the vertex form.
Oh, it's the vertex form! So what do you think we're supposed to be looking at when we
Vertex.
manipulate these sliders? The what?
Vertex.
The vertex. Notice, here's the equation right here. You see how it's in red and the graph is in red? So this equation, f of x equals a times x minus h squared plus k, that must be the which form again?
Vertex.
Vertex form, right? We're looking at the vertex form here. Now, before we do get started, there's two things I want to ask you. One, not just looking at the graph, just looking at the equation, how should we know that this was a parabola, that it was a quadratic?
Because it's a parabola.
Without looking at the graph. Just looking at this equation,
Because
it's
squared.
raised to the
X squared.
it's raised to the second. Now, be a little careful there, because is x being squared? No. The whole x minus h is.
Yeah.
But it does allow us to lead into something else. When we square something, what are we doing? Repeatedly multiplying. So what am I multiplying?
Everything that's in.
X minus h.
Yeah.
Times what?
Minus H.
X minus h?
Uh-huh.
Now I have the product of what?
Two linear expressions.
That's what I want you to notice, right? X minus h squared is still the product of two linear expressions. So is it a quadratic?
Yes.
Yeah, right? So I want y'all to notice that this fits the bill. This fits exactly what we have learned of, hey, the product of two linear expressions. Hey, you're good. Yes. Yes.
Zero.
This one too. This one as well? Alrighty. Yes, ma'am. Very good. So I do want you to notice that idea. Mark her down. So we have the product of two linear expressions. So this should in fact be a quadratic. Now once again, what you're going to be doing is manipulating a, h, and k at different times. And they're going to tell you which times to do that. Go ahead, actually, okay. No, I'm going to do this instead. Once again, what should we be focusing on for this form of a quadratic equation?
The vertex.
The vertex, right? Where is the vertex?
Right there. 3, -4.
Thank you, 3, -4. That's my vertex. Right now, that is the what of the parabola? There's an M word. Minimum, right? That vertex right now is that minimum of the parabola. Notice I say right now because it's not always a minimum. You'll get into that later. Okay. Now, one of the questions that they're going to ask later within this task is called the axis of symmetry. What do you think they mean by an axis of symmetry? Do you see any symmetry here in this parabola? No symmetry at all? I'm telling you there's an axis of symmetry. The bottom? Okay, so it's saying an axis of symmetry. There is a line of symmetry somewhere up here. Do we see it? Where do you see it, CJ?
Like, it's all like the same thing.
Say it one more time.
Like it's on the same thing on both sides.
Okay, where do you see a line? What kind of line do you see? Is it slanted, vertical, horizontal? You're right on the idea of symmetry, but where do we see the symmetry up here?
On the sides,
Everywhere.
What do you mean on the sides?
like not in the middle. You see where that 3 minus 4? Is that
The what?
The 3 negative 4. You see what that is?
Yep.
Right. So not the sides of the parts that go up.
Yeah.
So like this part
Yeah.
and this part?
Mhm.
Okay, so where's the line of symmetry?
Right in the middle.
Right in the middle? What kind of line is that?
Vertical.
Well, there's a vertex here. What kind of line is it?
Vertical.
Horizontal.
Do we not know the difference between vertical and horizontal?
Nope.
It is vertical.
That's vertical as can be. Up and down is vertical. Left and right is horizontal. Okay? Gotta know that. So there's a vertical line here. So this axis of symmetry is a vertical line. And what it's going to ask you about later is what is the equation of that vertical line? Anyone know? No idea, right? It's very common sense though if you look at some points. This point right here, that's 3, 7. This one, 3, 5. This one, 3, 2. This one, 3, negative 1. This one, 3, negative 6. Man, what do all of these points have in common?
3.
3, not just 3. What about that 3?
It's 5.
It is positive. But if I were to look over here, I could make a parabola now on this side, and I would still have a vertical axis of symmetry. But now this point would be negative 6, 5. This point would be negative 6, 1. This point would be negative 6, 3. Negative 3. Yes, all of these 3's are positive, but where are they located?
X.
Not on the x-axis, but on the x value, right? So what is the relationship here between x and 3?
X equals 3.
Is x always equal to 3?
Yes.
Doesn't matter what y is, x is always equal to 3? So what's my axis of symmetry? X equals 3. What would be my axis of symmetry here?
X equals negative 6.
Do you all agree with that statement?
Yes.
Now I want you to notice this vertex right here. This vertex right here, isn't the x value the same as the axis of symmetry?
Yes.
Okay, use that to help you later on. We all go with that. Now you need to put that on the back burner though. What I want you to do is notice that this first question is all about adjusting the value of a and observing what happens to the graph. Alright, really quickly, you'll come back in a second, but click next at the top right hand of the graph. What does it ask you to do?
Describe how the graph of parabola changes when the value of a is positive and the value of a is negative.
Okay, so describe how the graph or the shape of the graph changes or something like that. Describe how the graph of the parabola changes when the value of a is positive versus the value of a is negative. If you don't know that answer, what should you do?
Check.
Ask Mr. King.
Don't ask me. I mean, you can do that too. But can you go back to the previous slide?
Yep.
So go back and play around with it again. Pay attention to what those questions are asking. If you're not sure how to answer it, come back afterwards. We ready to go? All right, let's get to work within our groups. Oh, that's what I'm gonna tell you. When you go to that slide where it asks you to make notes, do that individually. Once you have each individually made notes, coming up with what you think is happening, talk about it amongst your group. The stuff you talk about within your group is what you want to write down on this sheet of paper. Right? So your small group discussions go on this sheet of paper. Your initial thoughts go into Desmos. We good with those ideas? Alright, so let's start exploring A. When you get done with A, make your notes, talk about it as a small group, and then move on to the next part after that. Let's get to work. Come on, buddy, it helps to